Welcome. This video focuses on how we correctly handle the destruction and copying of objects that manage memory. So let's start with the destruction. There is a part of every object called the destructor. And the destructor is kind of like it sounds, the opposite of a constructor. A destructor's job is it's a special function that's going to run any code that we need to clean up after an object, to break it down. And what that looks like, a destructor, kind of like a constructor, always has the same name as a class. A destructor always has the same name as a class, but it has a tilde in front. So if I've got a class polygon, the destructor would look like this. And if I want, I could just have the destructor do some printing. Kind of a silly thing to do, other than if I do something like that, I can get messages when a particular variable is destroyed. So I write myself a polygon class, it has this destructor that prints out destroying a polygon, and I run this code. So main starts up, makes a polygon my quad with 4 sides. I call foo, so we go off to foo, we make a pentagon with 5 sides, we exit foo. Well, when we exit foo, we're going to lose this variable. And this pentagon, this polygon, has been allocated on the stack, right? I never said new. So it's going to go away. It's going to be destroyed automatically. And here's the message I get. I made the polygon with 4 sides, then with 5. Oh, we destroyed the polygon with 5 sides. Then we come back, we finish running main, we leave main, and this polygon that was on the stack as well gets destroyed, and we get that message. Well, if we have something on the heap, we have to destroy that manually, right? And we know this is the delete operator. So if I run the same code, but I have my quad is actually a pointer to a polygon, and it's holding the address of a polygon that I've put out on the heap using new, and I'd run this same code, and I'd never end up destroying the polygon with 4 sides. I can see that the destructor never got called. If on the other hand, I insert this delete my quad, well, that's me stepping in and saying, look, I know you don't know when this thing on the heap's going away, but I'm telling you to get rid of that, to go destroy that polygon. And as part of doing that, the destructor gets called again. So whether it's something on the stack and this happens automatically, or whether it's something on the heap and we choose to do it, we're going to hopefully have this destructor run when we're done with the object, and this is the logical place to do cleanup. Right? Anytime we've got an object that's managing something, and what we're going to be focused mostly on is managing memory, but we could also use the destructor to handle things like closing a connection to the database, closing a file, right? Releasing any kind of resource it owns. But the more common example, and the one we're going to be focusing on, is things that manage memory. If my polygon class stores a list of points, so I can have a triangle object with 3 sides, and it maintains this array of vertices, this array of points, each with an XY coordinate. Well, every polygon is going to have, if that's got a different number of sides, it's going to need a different sized array. So in order to be able to create these arrays of whatever size, in my constructor, I'd allocate an array on the heap. Right? For dynamic size, that's how I have to do it. And so if I have this foo function, I could make my triangle, I could set up some vertices, and I'd have this in memory. Well, I leave foo, my triangle object disappears, but because I haven't provided a destructor that does anything about the memory, that memory's sitting around, I've got a memory leak. So the destructor is kind of the natural place to take care of that. So if my constructor allocates a memory, it's pretty much a given that I'm in charge of that memory, and in my destructor, I need to delete that array. I've allocated an array, so I'm going to delete that array. And that way, anytime my either variable goes out of scope if it's on the stack, or I call delete on my polygon that's on the heap, we're going to clean up the array that my object was managing. a similar, obviously a different idea, but a similar issue is dealing with copying an object. So every object has a destructor that doesn't do anything terribly useful, unless we pretty much want to write our own if we're going to be managing memory. Every class also has a built-in copy constructor. And the copy constructor always looks like it's a constructor for whatever class, and it takes in a reference to another thing of the same class. So for a point class, the copy constructor might look like, hey, I make a point, I take in another point reference, and I just copy from that other one's x to our x, other one's y to our new point's y. We don't actually have to write this. This is created automatically and visibly for us. And it's why I can do things like just, I can use an initialization list for a constructor. I can say something like, hey, initialize this point to be this other point. Well, what's wrong with that is this isn't always going to do what we want. All right, so here's an example of using this default copy constructor, which once again, I don't even have to write this, but if I don't write it, this is what the code would be like. So I start off with, hey, I've got P1, which is at 4.3. This says make me P2 and use P1 as what we're going to construct it with. And so we'd go down and we execute this phantom code. And P2 would end up with x is 4, y is 3. Okay, let's take this idea now and look at it in terms of something that manages memory. So I've got my polygon. And polygon, my triangle, I set up this one triangle. And now I make polygon try2, that is going to copy my triangle. Now, if I don't write my own copy constructor, I get this phantom one for free. And the phantom one is going to take a polygon reference called the other and use it to build my polygon. It's going to take the other sides, copy it into my sides, the other's vertices, and copy it into my vertices. Well, sides, that makes sense. The other triangle's got 3 sides, I'm going to have 3 sides. The vertices. Well, it's got this memory address for the array that it allocated. All right, so here's the basic constructor. And the basic constructor, when we made the other triangle, the original one, it allocates this array. And it stores that memory address as vertices. So I copy that memory address as my memory address. Well, what does that mean? It means that we're both pointing to the same object, that same array of points. This is what's called a shallow copy, where we have 2 objects that we think are distinct, but they're sharing the same chunk of memory. So if I went right now and I took triangle 2 and I started changing its x and y values for this particular vertex, my triangle would share those as well. And even worse, if my triangle, if the original goes out of scope, if it gets deleted, it's going to delete that memory that it thinks it owns. And now try2 is going to be pointing to this chunk of memory that's been blown away. Shallow copies are pretty much not what we want if we're managing memory. Right? If our class is hanging on to pointers, and we're trying to actually make a copy of an object, we probably want to copy the memory that it manages as well. That's a deep copy. So a deep copy of my triangle would be something like this, where we copy not just, oh yeah, the sides are 3, but we go and we copy the whole array it has into a whole new array. So to do this, kind of like if I want to provide better logic for a destructor, right? So if I want to have my destructor actually clean up after me, I have to go explicitly write a destructor that deletes the memory. Well, same idea. I need to go write a copy constructor of my own to replace that invisible one I would get. And so what that would look like, I make sure it takes in a reference to the same type of class. Calling it other, I could call it whatever I want. And the basic model will always be to copy any non-pointers So his sides are 3. Well, wonderful. My sides are going to be 3. All right, I can just copy that straight over. Anything that's an array or a pointer, I have to go make my own copy of out on the heap. All right. So he's got this memory address of an array. Well, that means I need to allocate a new array of that same size. So I go make my own array with 3 points. And now, making my own array with 3 points, there's no magic way to kind of copy that old array into this new one. So now I've got to go loop through, and for each of the 3 sides, the 3 vertices, I need to go get the other guy's one and copy it to my one. All right, so I'm going to loop through here, and I'm going to copy his vertex number 0, then copy over number 1, copy over number 2, and go through and copy piece by piece everything in that array. And now what I've got is my own complete copy. Right? I've got a deep copy of my triangle. I can go off and mess with this triangle and not affect the original. I can have one of these get deleted or destroyed, and it won't affect the other one. That's generally the behavior we want when we're trying to make a copy of an object. So we get done with our copy constructor, and this is the state we're in. There's this idea of the rule of 3. And basically it's just a rule of thumb that if you know you've got an object that's in charge of memory, right, so it's got a pointer, and it's the object we've determined is responsible for that memory, the one who needs to delete it when we're done with it, we need to provide 3 things. We need to provide a custom destructor, a custom copy constructor, and we need a custom assignment operator. Because assignment operators are similar to copy constructors in that when we do an assignment, we normally think of it as we're going to copy this thing on the right-hand side into the thing on the left-hand side. And if we're doing a copy, we want to make sure it's a deep copy. Now we haven't gotten to overloading operators yet, so we'll get to the assignment operator later. But this rule of 3 is these 3 things that we always need to override if we're managing memory. If we've got a simple class that isn't responsible for memory, we don't have to worry about these because the default versions will work just fine.